Okay, we're starting the session. Um, it's about enterprise-grade rolling upgrade for a live Hadoop cluster. I'm going to give a brief introduction, explain what rolling upgrade is, talk about several key problems that we had to solve in order to make this work, and we'll then go into details about these enhancements that we have done in order to make rolling upgrade truly work. Okay, so hello, my name is Sanjay Radia. I was part of the Hadoop team at Yahoo since 2007, about a year after Hadoop started. And I was the chief architect of Hadoop Core at Yahoo, and I'm the chief architect right now at Hortonworks, one of the company that I founded. Prior to that, I did a lot of work on data center automation, schedulers, operating systems, HA, file systems. I have a PhD from University of Waterloo. So what is rolling upgrade? So traditionally what Hadoop has supported is what we call stop the cluster upgrade. Okay, so we have to stop the cluster, shut it down, and then upgrade it. Okay, and this is traditionally the only way to do that. Okay, clearly this does not work for enterprises that are running critical services and data on a Hadoop cluster. Many of our customers are actually using it for live online systems, and you want to be able to maintain the SLAs without degradation, let alone bring it down. And so what we have is this thing called rolling upgrade, where you upgrade the cluster and services while the cluster is alive. Okay. Typically, the upgrade time is proportional to the number of nodes. It's not proportional to the data size. Okay, because no data is actually copied during a rolling upgrade. Upgrade also offers a way for you to do a downgrade. So let's say in the middle of half the cluster, you see that things are not going well, the performance is degraded, or something is happening, you can downgrade. In fact, you can even downgrade after you finish the whole upgrade. And you will not lose any data that you created during the upgrade. The other kind of thing that is supported also is rollback, where you're really going back to a checkpointed state. And this is typically only used when there's an emergency, there's a real problem. So generally, you want to use downgrade, not rollback. Okay? But it's a nice safety net to have. So one of the, so in the community, I think when the big thing that was not there in the community for a long time was wire compatibility. And so the community kind of felt that once we do wire compatibility and do some sort of a side-by-side install, then you're all done for rolling upgrade. It is all finished, okay? And it turns out it actually, unfortunately, was not true. Okay, we were too quickly to jump to that. So if you really want data safety, and I'll talk about that, keeping jobs running to continue and to run correctly. There were things that needed to be done if you wanted to maintain your SLAs and not have a degradation. And again, to have this downgrade rollback feature for data safety, okay? Those things were not there. So what are the issues? HDFS had an upgrade checkpoint, in fact, since release, since 2007. In fact, when I joined Yahoo, they already had the notion of a checkpoint during upgrade, which is the stop the world upgrade. And that did not work at all for rolling upgrade. There was service degradation when the write pipeline would, of course, fail. Masters would restart, and because every daemon in the system is being restarted. Okay? So the question, of course, was, wait a minute, why worry about this? Hadoop actually brilliantly deals with failures. It'll fix pipelines, it'll restart tasks. What is the big deal? Why do you have to solve these problems? Okay, and it turns out you do, because you will otherwise get a fairly high service degradation, because you predictably going through every single node, every single daemon, shutting it down and starting into the next one. So the number of failures and task restarts you will have is going to be enormous. Okay, will it work? Of course it'll work, but you will have the kind of degradation which is pointless for rolling upgrade. Okay, it won't be as bad as stop the world, but it'll still not let you maintain your SLAs. And the other one is there was correctness issues. So for example, yarn tasks would get a mixed context. It really needs to maintain the context of the job submitter. And now there are two versions of the binary, and the code that was at that time in both Hadoop 1 job tracker and in Yarn was that the binaries would be taken from the local node and you will get an inconsistency. So if, for example, your node manager was already upgraded, it would get that node manager's binary. And so this was something that needed to be fixed, okay? Again, all the persistent state typically was backward compatible but not forward compatible. And so we had to deal with that issue, make sure that all the persistent state is versioned to be backward and forward compatible very easily. Okay, and wire compatibility, clearly I mentioned there is some work that we did, but between in some parts of Yarn and other services, they did not have the kind of same wire compatibility. And so we really needed to work through the stack to make all of this happen. Okay, so I will talk about a number of these enhancements that we have done and start with the packaging and what we did, and then I'll talk about the other ones, okay? So packaging, what we need is you need to, because you're doing a rolling upgrade on the same physical node, you will have some components that are version n, some components that are version n+1. In fact, for the same component, you may have a daemon running on the same machine that is n, and another daemon is n+1. Example, if you happen to run the name node and the data node together, you typically in a rolling upgrade the name node first, and then the data node. So that means your side-by-side install must support that, okay? So the solution that Hortonworks chose was to use an OS distro standard packaging solution. Okay, we rejected a proprietary solution. We felt that would kind of be a lock-in. We didn't need it. Second reason was we wanted to support rolling upgrade via Ambari, which is our automated install mechanism. But we also wanted to support customers that are not using Ambari, because we have customers that have their own scripting mechanism through Puppet and Chef, and we didn't want to kind of leave them behind and force them to move to Ambari if they prefer their own solution. Okay, so we decided to go with the standard packaging solutions like RPM and DEBS, because they have a set of useful tools. They have tools to install, uninstall, query what is going on. Okay, they have tools to go and get the packages from a cloud location. They have tools to install a copy of that repo in their organization. We had to kind of rebuild some of the tools. First, we'll have to retrain IT departments. Second thing, we'll have to add notions of managing dependencies, et cetera, and just wasn't worth it, okay? Now, there's another benefit to side-by-side install. It actually helps even non-rolling upgrades. Even if you're doing stop-the-world full upgrade, it is really nice to install all your binaries, make sure it's all installed, and then stop the world and do an upgrade, okay? So what is the solution we picked? It's very simple, actually. What we did was we put the version number in the package name. So Hadoop _2200 is actually the RPM package name itself. And Hadoop 2300 is actually a different peer package. It's a related package, but it's actually a different package, okay, strictly speaking. So our layout looks like this. We install it on /user HTTP to Hadoop, user HTTP to Hive, et cetera, for the different components, okay? By the way, we, of course, chose user HTTP, but it's a fully relocatable thing, okay? Then when you install 2.3, the version number will be there. Obvious, nothing, no rocket science here. Now, what happens? So let's say you upgraded the name node, okay? Then the HDFS name node will have a link to, so there's something called current, as you can see. Let me, this one here. So current points to the current for the name node, and it says name node is upgraded to 3, okay? So by the way, HDFS and Hadoop have the same package, okay? That's why that works. Then you might have, of course, left the Hadoop client and the data node still back at the original version. That's typically what we do, but this gives an example of one component upgrade, the other one's don't, okay? Now, there's a tool called distro select or HTTP select that lets you manage how to version and switch each of the components individually. And our Ambari system calls it, your scripting mechanism can call that. Then bin, by the way, the bin commands, user bin Hadoop, points to whatever is current, okay? And so when we install it, always know what is the current, and it uses that, okay? So this is a way we do the packaging. As I mentioned, there's the distro select to let you select the binary per component per daemon, okay? And then we maintain stack consistency. Now, it's very important that Hive 2.3 uses HDFS 2.3. If you don't, it possibly might work, because there's a lot of compatibility. You know, especially Hadoop and HDFS are compatible. But that's not what was tested as a stack. And therefore, you want to maintain that stack consistency, okay? Whether it is Hive or Tez or whatever components. And so what happened is each component refers to its sibling with the same version, and the notion of a Hadoop home that we put in the wrapper bin script. So you know, all the Hadoop commands have a wrapper script, and what we've done is we put an umbrella around it that does it, which is roughly what Big Top did, okay? So we've added that thing in so that there is stack consistency, okay? Second thing is that that we also have done is that the configs can be optionally synchronized with the binary upgrade. Okay? So when you're upgrading the binary, you may occasionally, very rarely, but occasionally may want to go and upgrade a particular config variable or add a config variable. And we allow you to optionally do that, okay? And each binary has a config that points to what its current config location is. In general, you'll point to etc. Hadoop config or etc. Hive config, and it'll work. But and you typically don't need to do a synchronized upgrade of the config. But in the cases that we need to do it in the future, we support this. So we've looked at a packaging solution for both config and for this very, very carefully. Okay. Next one. We're going to now talk about HDFS enhancements. So what I talked about, since 2007, we had an upgrade checkpoint. Okay. Now, because if any of you have ever gone and upgraded a system like ext3 or your Windows system, it says, please back up the system before you do the upgrade, right? And you do most of the time. If it's a serious upgrade of the file system format, you will back up. Hadoop, that's not practical. You got maybe 40 petabytes, some of you, and where are you going to go and find another cluster in 40 petabytes? Tapes are not practical sometimes. So Hadoop has always had a notion of an upgrade checkpoint where it does hard links. And the reason you need this, it's a safety net. Okay, we've only seen one case where there was a problem in 2008. But remember, Murphy's waiting there to strike and catch you. And so what it did was it would do hard links. So if the name node ever came up and said, due to a bug, I don't have any files, because it reads the image and this is a bug and it thinks there are no files. It'll promptly go and tell all the data nodes, delete all the blocks. Nobody's referring to them. And it can actually delete your nodes in parallel like this. It'll tell every data node. So that feature was always there to do hard links so that if ever there was an error like this, there's a safety net. And none of that worked because the stop the world required that every data node was down and then upgraded to the new version. And so and doing a rolling upgrade without such a safety net, even though you may only need it every 5 years maybe, okay, it is irresponsible. So we fixed this problem, and we put markers for rollback. We did, instead of using hard links, what we do is we do delayed deletes. So if you're in an upgrade mode, the data node will not do a delete, it'll actually at that point do it. So it's a slightly different mechanism, but the same idea. And we added the downgrade capability because that was not there in the stop the world. And in the FS image, we made it protobuf so that we can actually maintain forward and backward compatibility a lot more easily. Okay, to let you downgrade even when we've made changes to the image. Okay, so the second enhancement we made was a faster data node restart. But a more important one was the write pipeline. Every data node will be upgraded. Yes, the pipeline will break and HDFS will fix the pipeline. But what you don't want to do is to go and connect up to a different data node, because then you'll be forced to copy the data. Or worse still, the HDFS data node says, I can get away with 2 replicas. And what you're doing is you are then running into an issue of potential data loss if you have 2 more data node failures. Okay? So there's a repair thing that we've done, and we reconnect back to the same guy. And this is a very important one from a performance point of view. Okay? And then, of course, generally you would use HA for, and this name node HA has been available for many years now. Okay? Next one I'm going to talk about is YARN enhancements. Okay? So by the way, when we finished the HDFS 1, Yahoo started to use, this was last year, Yahoo started to actually do HDFS rolling upgrades since last June after we added that feature in. And they've been successfully doing it and having absolutely no problems, okay? And now YARN also has some of the issues. So YARN RM since 2013 used to retain the application job queue. If you restarted it, it would restart all your tasks and all your jobs, okay? Yeah, a little bit painful, but not bad. Okay, and then there's, of course, the RMHA that was done in 2014. Again, it'll restart everything. But this is not good enough for rolling upgrade, because you're going to redo all that work. You're going to have a serious service degradation, and the promise of rolling upgrade is my cluster is live. So what did we do? We added in 2015, January, we completed all this work, where the RM can start, it retains not just the application list that was originally there, that was the one that we had done in 2013, but we now synchronize with the node managers of running task and with the application they resync. It deals with all sorts of situations where even things that might have failed or completed after the RM went down and up. It deals with all those kind of funny corner cases. And this was completed, and this now lets you have the RM not go and restart jobs. Okay? So that's and there's a second part to this. What about the tasks? How do you retain the running task? And so what we did over here was another feature we added, okay, what we call container recovery. And what happens over there, these are the running tasks, and there's some finished tasks. This is the old node manager. It used to manage these guys. And when the node manager, the new one comes in, it actually inherits all of these guys, okay? And deals with the case, well, for example, this running one might have completed while it was down, okay? And so it looks at all the exit files, everything, and it all works out, okay? Again, remember, restarting containers would have worked, but it would have been a degradation. So we fixed that, okay? Then other things we did was versioning of state stores, to make things much more easily to evolve down the future. Evolution of tokens over time. There was a thing that we should have done more correctly early on. We fixed that. And some minor fixes in the internal wire compatibility protocols, not the client side. There was a couple of things that we had missed, luckily. Because remember, you've got half of your slaves old, some of your slaves old and new, and then you have your RM new. When they talk to each other, you need to make sure you're fully compatible, okay? So, by the way, with both these things in there, Yahoo has been doing rolling upgrades for a while, okay? They have a 40,000 node system, multiple clusters. They approximately upgrade 1,000 nodes a day because they've got some patches, some fixes. All of this being done in rolling fashion. A 4,000 node cluster typically takes about a day or so to 2 days to upgrade because you're doing it in a complete rolling fashion, okay? But now doing it in live systems. Okay, the other one, again, related to Yarn, is the job context. As I mentioned, that you must run the job in the same context as the submitter, the same version that the submitter did. Otherwise, you'll have half of your tasks run the new version, half the tasks run the old version. Chances are it may work, and in fact, you probably won't even notice it, okay? But it'll occasionally be incorrect, and then you don't know what'll happen, right? So we fixed this, okay? And basically, the libraries are now installed in HDFS rather than in each of the nodes. So that's a big advantage. When you want to install a new version, bang, you go to any one of the nodes and install it and copy it into HDFS, you're done. You don't need to go and install things like TES libraries, MapReduce libraries, Hive libraries onto every node. It just goes into HDFS. And so that's the other side benefit, okay? And there's a client context passed as a distro version variable, okay? And there is another really benefit that actually has been a promise of Yarn from a long time ago when Yarn was created, that I can run now some jobs, old version, some jobs, new version. So you might say, you know what, there's some features that have come out in Yarn or TES, and I like to take advantage of that. But not all my other jobs, because I haven't had time to test their compatibility. These new ones will run just a new version. You can do that, and you couldn't do that before, and this was one of the big promises of Yarn, okay? By the way, Uzi had some similar issues about maintaining context consistency, and you also fixed that, okay? So the last one is the Hive enhancements. So we have done faster restarts of Hive Metastore, okay? The Hive clients did not reconnect, and so what would happen is if there was a failure, they would fail, okay? And so you really did not get the rolling upgrade transparent thing that you wanted. And this wasn't done because, Hive never had HA, okay? And so if Hive had done HA before, they would have fixed this problem, because for HA you always need it. All the other components like Resource Manager and HDFS had all fixed the client reconnection issue, okay? So because they didn't have it, they had not fixed this. The other one is that there is something called the Hive server, where normally, you can use the Hive CLI and submit a job. It goes via Yarn and runs your job. There's a second option where you go via the Hive server, and it's a stateful server that actually runs the job on behalf. So it's a thin client that connects into the Hive server. Now, you're going to shut that guy and bring it up, you would lose that context. Or if you wanted to remember the old state and have this guy shut down, there would be another complex thing. So those was something way to figure out how to fix. So what we ended up doing was to allow multiple Hive servers to run, each registered in Zookeeper. Okay, so that's a new thing. It didn't used to register. It used to have a fixed address. And new clients now, new client requests will go to the new server. Okay? And the old server, what it'll do is during a rolling update, it'll deregister itself, but will continue doing its old queries. And when all its queries are done, it'll shut down, remove itself from Zookeeper. And so now what you have is old and new running. And you have a side benefit. You now have HA, which never was there. And by the way, you have load balancing. So you can actually run multiple Hive servers and do load balancing automatically. Okay? So in fact, it is probably the best HA solution of all the other Hadoop, whether it's the RM or HDFS, because that HDFS is not active. This is kind of active. Of course, this is a much trivial problem to solve compared to HDFS. Okay, but it is pretty nifty solution. So we kind of solve this, and has an interesting side benefit. Okay. Now, automated rolling upgrades. So we have a thing called Ambari that manages, it's like Cloudera's Cloudera Manager. And so you can do rolling upgrades via Ambari, or you could do it via your own Chef Puppet scripts, okay? Okay, so typically what happens is that there's some bunch of prerequisites that you need to make sure are there. Ambari will take care of that. You install the bits, the databases are backed up, then you do HDFS checkpoint, okay? And then you would do the actual start the rolling upgrade. It'll take some time because you'll be doing node at a time, and then you would finalize. And if you finalize, you're done. If you don't finalize, let's say from this point you decide something, you can downgrade and go back. You could even roll back and shut down all. You could do an emergency rollback, okay? And as I mentioned, it's being used in production at Yahoo. And they're not using Ambari because they've traditionally had their own automated system for managing. And they've been using it very successfully. And in fact, the other good news is that Yahoo used to be on an older version of Hadoop 2, and they refused to move to the latest version till we had rolling upgrade done. So we used to work very closely with them, and now the good news is that Yahoo is on very close to trunk now, and they are on 2.5 or 2.6, which means now that all the systems that you guys are getting are all actually also been pre-tested at Yahoo, okay? And they were not willing to do it till both HDFS safety hooks were done and the Yarn enhancements that I did. And by the way, some of the Yarn enhancements were done by Yahoo, okay? So Ambari supports full rolling upgrade. It verifies everything, does the backup, prompts you to do the database backup because that's something that it cannot do. It's under your control. It does everything in the right order. Other thing it does, it runs smoke tests at each critical stage. So it runs smoke tests to make sure that things are actually working, okay? And at particular critical stage, it'll give the admin opportunities to verify that things are working from its perspective, and does he want to go back, okay? So, by the way, we have published the runbook, so you can do it manually. So typically what happens is that you will start rolling upgrade. Ambari will first go and do Zookeeper Ranger, and if you do your own script, you would do the same. Then after that, you would do core masters and core slaves. By core, I mean HDFS, Yarn, HBase. You would first do the masters, then you would do the slaves one by one. And the way you do the masters is you do the standby, bring it up, and then you fail over to the standby, and then you do the old active and upgrade it, etc. Okay, and you do the same thing for HDFS, the same thing for Yarn, and the same thing for HBase. After you've done that, you go to the slaves one at a time, and what Ambari does is after a certain number of slaves are done, it'll pause and say, okay, we've done this portion of slaves, go verify. So you could go and look at the logs on the data nodes you upgraded to see, did you see any error messages on those logs, etc. Ambari will do some of the checks, he'll do certain things, but you have your own way to validate. You will see, are my jobs failing? Are my jobs running slower? What is happening? Are the tasks running on those guys running successfully? Did those tasks fail? Did Yarn take them over? Based on that, you said, you know what, now I want to go forward one node at a time. Or you could say, you know what, something's wrong. Maybe we broke compatibility. We promised you, Apache promised you they will not break compatibility. They broke it. Some of your apps are breaking now. or you are using a hidden API that was not public and you shouldn't have used it, but you used it anyway, right? And now the new one, somebody changed it, it broke things, you have a way to go back, okay? After that, you do Hive and Oozie and Falcon, and after that, you do the clients of all of them. We do all the clients together after that. And then we do what we consider non-core, things that we consider to be kind of outside the cluster. They're not really outside the cluster, like Kafka, Knox, Storm, Slider, Flume, Hue, okay? After you've done all of that, you say, you know what? I'm happy, I finalize. If you're not happy, at any point, you can go back and downgrade. Example of here is in the middle of my slaves, you saw that problem, bang, you went back. Okay? Typically, you won't do that, and if there's a real serious problem where you try the downgrade, it fails, you will do what you call is a rollback. Okay? And the main difference between those two is that in a downgrade, during the upgrade, while this upgrade was happening, you had some applications, let's say, create some data here. All that data will not be lost. It will be retained because it's in HDFS. You're just downgrading it. HDFS continues to use the latest state when it's restarted. Its daemons are restarted. However, if you do a rollback, it goes to a checkpointed state, in which case any files you created during this process, during this upgrade process, will be lost. Not nice, but that's an emergency situation. You know, it's like something went wrong and you had to go to your backup. So that's what it is, okay? And so to summarize, enterprises run critical services, and we support live cluster upgrade without degradation and maintaining the SLAs. In order to do that, we had to enhance a number of things, okay? So, you know, wire protocol was not sufficient to make this work. We have used a non-proprietary packaging solution. We use OS standard solution. We use the package that is specific to the OS, whether it's RPMs or DEBs, okay? Something similar on Windows. There's data safety, there is HDFS checkpoints, there is write pipelines, and we maintain the SLAs, okay? And there were a number of serious degradation problems that you might not have noticed, okay? But if your cluster was heavily loaded, you would have noticed it, okay? And we fixed those problems. As I mentioned, the pipelines, YARN RM, state recovery, etc., the context, and then we allow both downgrade and this, okay? And as always, all our enhancements are truly open source, pushed all the back to Apache. Did we do that? Yes, we pushed every single thing back. That's how we do business, okay? So that's my very last slide. I've got 12 minutes to spare. Questions?
For the package versioning, why didn't you use the built-in version controls in the package managers instead of doing name-based versioning?
Yeah, we thought about doing that, and they weren't going to be the same as like with DEBs and RPMs. That was one thing. And the second thing is we still wanted this tech consistency to be built in. So we looked at doing that, okay, and this we felt ended up being better. We talked to a number of admins, okay. We talked to Alan, you know, who's been an admin long before Hadoop, and he's now a pretty strong Hadoop admin, and he also advised us to go this way. So we talked to a number of admins. We originally were looking at that, okay? So in order to do the stack consistency, the fact that there were multiple packaging solutions and all of them had different variants of it, we went with this way. It actually ends up also helping us deal with dependencies better, because then the stack dependencies that this version of Hive depends upon this version of HDFS and YARN, et cetera, et cetera. Okay, so it worked out better there, because there the dependencies are really tied to stack consistency, and that's why we did it that way. So, but we did look into going down that path. Okay.
How do you handle cleanup of old packages?
Oh, good question. So after the upgrade is done, you could keep the old packages around. You could keep 3 versions of it around if you liked, okay? But at some point, you could basically go and say RPM uninstalled Hadoop 2.2, because you've already moved to 2.3. It's been 3 months. You're happy. You're not even going to do anything, okay? Go back. So you could do that, okay? So Ambari will take care of it for you. If you're using something like Ambari, it'll come and you can go and uninstall the old versions if you like and when you like. If you are doing your own manual system, you can go and uninstall those packages using the standard tools, okay? The only snag is that you need to go and do all of them. So you could say, I uninstall, Hive and this version, 2.2 version. So there's a set of things.
You have automated that in Ambari if you use Ambari.
Yes. Okay. Yes.
If you're using a central repository for this rolling upgrade, how do we manage the package, different versioning of the packages?
So they will appear in the repository as, you'll see Hadoop 2.2, you'll see Hadoop 2.3, etc. So you will see what appears to be totally unrelated packages. So you will see multiple packages there. It'll be different than, I think, what the other gentleman mentioned, that, yeah, if he had used the internal versioning, from that point, your repository, everything would have looked slightly better. But here you will see multiple stacks, and you will have to manage that. So you will go and say, I've got this stack, and do that, okay?
So in case of central repository, we always take the latest version.
No, we don't actually. So what we do is that's actually the beauty. So there is no notion of latest version. So if we had done the internal one, that as the gentleman mentioned, there is a notion of a latest version. Here, there isn't a notion of a latest version. It is latest because of the name of it. So there is no latest version of Hadoop that RPMs understands. So you can't say upgrade, okay? So in that sense, you will have to say, now I'm installing this. Now I don't know whether we finished this or not. What we were going to do, we may have already done this, is to have a wrapper RPM called Hadoop, which knows that it has a dependency on Hadoop 2.3, and then it used to be on 2.2, and now it's on 2.3. So if you upgrade Hadoop, it'll go and upgrade. I think we might have pushed that through, I'm not sure. So with that, it would have made actually life a little bit more simpler. Okay, maybe even the cleanup, I'm not sure. I need to think about that, but it might have made it. We were going to do that, and we might have pushed that out. Okay? You had a question.
Yeah, I actually have two questions. So first, an
ahead.
operational one. You mentioned how after you do your rolling upgrade, then you finalize your cluster. Typically, how long would you advise waiting in between finishing the rolling upgrade and then actually finalizing your upgrade?
I would say depends upon how active your cluster is. So generally, the modulo one issue, okay, I'll explain to that. I would say if this issue wasn't there, it's not an issue, it's a nature of HDFS. I would say wait for a week, wait for a month, what's the problem, right? But here's the stuff. Because in the old upgrade scheme and in the current one in HDFS, the checkpoint we have done, we are not deleting new files. Sorry, we're not deleting files. We are keeping copies. So really, you have to kind of watch your capacity. If you have got a lot of very little capacity, then you should delete faster. You should finalize faster. If you've got enough capacity, wait a little bit longer. Disks, these disk blocks are going to be used up. They're not going to wear out, so you might as well do that, okay? So that's the main thing that I would wait. Typically, I think, I should actually ask the Yahoo guys next time I see them, how much do they typically wait, okay? But I would say I would easily wait a day, because after you do the finalize, you cannot really do a rollback, okay? I believe you can still do a downgrade, because downgrade doesn't care about finalize, okay? I don't think the HDFS software used to support that. As the patch was done, I think we have fixed that, okay? So, but the safety net is in the rollback one, okay? So once you do that, you cannot go back, okay? And you'll start deleting the blocks as soon as you finalize. Okay, so that was the answer. And you had a second question.
Right, second question is actually about HDFS named node metadata forward compatibility. Last I checked, we actually changed the metadata version very commonly between minor releases upstream. So do we actually have forward compatibility between minor releases?
Okay, so what we've done is if you go and take a look at, there was a Jira that ATM from Cloudera, or maybe it was Collins, filed, okay? I've added a comment to that. It's a slight variation of the solution that Todd gave. And so basically, we have proposed a thing over there, how to deal with that issue. And so the good news is that there is a versioning of the images could actually go back, okay? And so what we have proposed is a scheme where we distinguish between where a downgrade would lose data versus a downgrade would simply lose functionality. Okay, number one. So that's what we are proposing as a thing going forward. Second thing that we have proposed, which is very easy to do, and we've got a Jira out on that, which is that basically during the upgrade, before the finalize, we will not let you use the new features. And before that point, we will write the old version, and we will write the old version of the image. Okay, and there is a slight issue with the there's actually isn't if you do that, there's no issue about the edits either. Okay, but if, for example, once you've done that, our edits and our images do not have different version numbers, and they should have had different version numbers, because sometimes you may be compatible in the image but not compatible in the edits, and what you really want is to do a save namespace and then go back. Okay, so there are a couple of things Jira's out there to address exactly that problem, because in 2.7 we added truncate, we added something else, I can't remember. Truncate, of course, breaks, you will have data loss if you use truncate and go back. And there was another thing we added where what was it? Oh, variable length blocks. Okay, that one does not lose data if you go back. Okay, so we are fixing that, but very good question.
Thanks.
See, this guy knows his HDFS. Of course, he's a HDFS committer. Sorry? Oh, good thing about Ambari is Ambari you can go and upgrade anytime. Ambari itself always had a live upgrade. Okay, so Ambari's had that feature almost from day one. Okay, question?
So does Ambari know which is the current version of any package? Because you said that it doesn't know, it doesn't care which is the latest version, because we might have multiple versions, but does it know, I mean, in its database, which is the current version of, let's say, Hive, HDFS? I'm asking, for example, a real-life scenario. We do automated upgrade. A couple of Ambari agents are lost, so it can't connect to them. It fails to update these machines, and they reconnect. So if Ambari knows which is the current version of the stack or any component, it might actually alert us or show us that these machines run an older version.
Yes, Ambari does know exactly which machines have upgraded, which machines have not, which components have upgraded, which components have not. Okay, so Ambari has that information. During the upgrade, Ambari will show you what stage it is in, during what stage is it is in during the rolling upgrade, what it has upgraded so far, what it hasn't, whether the clients have been gone or not. So Ambari knows that. Actually, I was going to put a picture of the Ambari rolling upgrade. I didn't get a chance to do that before I did it. But yes, Ambari knows that. If you're doing manual, the way you would know it is you would go to user HTTP current, and you will see what is current for each of the components, and you will know which of your components has done, but you will have to go to each machine to do that. So manually you can do it, and Ambari does know. Does that answer your question?
Yes.
Okay, so you would go to /user HTTP /current, and you do an ls of that, and they'll show you that Hive is pointing to 2.2, HDFS is pointing to 2.1, for example. Okay?
Yes, Ambari has service checks, right? I mean, you can check whether a service passes its service checks and it's.
Oh, got it.
But let's say we have a couple of machines which are not upgraded, or for.
So each of the services on their web page do display their version. What we don't have is we have commands on some of all Hadoop components don't have a command to print its current version. Some of them do. So and we are going to go and make sure that all the components do. Okay, so for example, Yarn already has it, and you could go to its, you could do a REST call on Yarn and ask it what version you're running. The HDFS name node doesn't have such a convenient REST. You could look at its log file or its main page. Okay, and so we want to try and make this fairly uniform across all the components. Okay.
So what is the, let's say you have a long-running service on your platform.
Sorry?
The long-running service or a job it might run for days.
Oh,
or yeah.
the long-running service or job will always be running at the version at which it was submitted. In fact, we had to fix bugs to make that happen.
Okay.
Okay? Well, by the way, one of my colleagues who worked on rolling upgrade and co-author is Vinod. He's at the back. He just came in. Okay? So you can ask him the tough questions. Okay? Anybody else has got any more questions? We still got 5 seconds. If you raise your hands, we'll let you. So either it was a boring talk and you have no questions, or you understood everything. Okay.
I think it's a great thing that you've done. Like, it's a huge step in the right direction, because this means that you don't have to run legacy applications and shit because you can't upgrade. So you can always keep it upgraded. Since many of these things are internet facing or partially internet facing, it's tremendously important to keep them upgraded. Because also when you aggregate all your data in one point, when you get attacked, when you get cracked, they will also get all your data at the same time.
Yes.
So it's super important to keep it upgraded.
Yes. Thank you. I didn't pay him to say that, by the way. But yeah, that's why we did it. We in fact, you were right. We should have done this a long time ago. Okay. And we thought that when Wire protocol was done, we thought all the work was done. And then as we started to go down the path, in fact, we were telling Yao, let's now get you guys to the latest version. They said, no. Okay, we can't. These are the missing pieces. You
Yeah,
know,
also now when we have so much data stored, and it's also stored structurally, and you have tools to pull it out, when a company loses their data, your credit card number is the least important data they will lose. There will be so much more important things that
they will lose, yes.
they can run jobs on your person if you are unlucky. So
Okay.
upgrading is super important.
Okay, thank you.
Yeah, but you can read it, so can them. If you can read your data, someone else can too.
Okay, one last question, because
Yeah,
we also
the-
got to get ready for
That
the next.
enhancement about the hard links, it comes with HTTP 2.2, right? The
Sorry, was
hard links in the data nodes that actually point to 2 versions of the data. It comes with HTTP 2.2.
Say that again, because I was looking. I thought the other guy was talking.
Ah, sorry.
Repeat
You
it, please.
mentioned that there are 2 enhancements for HDFS to support rolling upgrades. One of them was hard links. It comes with HTTP 2.2, right?
Yes.
Okay.
Okay, thank you very much. I think we're out of time, and they're going to get ready for the next talk. Thank you.